What are like terms?
According to Wikipedia, in algebra, like terms are terms that have the same variables and powers. The coefficients do not need to match. Unlike terms are two or more terms that are not like terms, i.e. they do not have the same variables or powers. The order of the variables does not matter unless there is a power.
Thank you.
I aim to please.
See, even the thing that doesn't have a face knows what they are. Like terms are those terms that have the same variable in common. So stuff like 5x and 6x would be like terms because they have that x in common. Same with 7t and 13t. Those have the t in common, so they would be like terms. And furthermore, the same thing with like 5 and 7. Those are like terms because they don't have any variables and they relate to each other because of that. Examples of unlike terms would be stuff like 5x and 6t. Those are unlike terms because they don't have the same variable. One has an x, one has a t. Same thing if we said, say, 7t and 13f. Those are unlike terms because they have different variables, a t and an f. Furthermore, 5 and 7x would not be like terms because one doesn't have a variable, the 5, and another does have a variable, 7x. You can't do anything with those, you can't combine them, can't do anything because they don't have that likeness, that either lack of variable or variable that's the same between the two of them. Now, like terms have some special properties that we can work with to make them either bigger or smaller, but ultimately put them together and make it easier to work with. Namely, we can add and subtract them together. And here's a couple examples of that. If we look at the top two here, we have 5x plus 6x equals 11x. We can combine 5x and 6x with addition because they have the same variable. They're like terms. The same thing with 7t. 7t and 13t. We can subtract 13t from 7t and get negative 6t because they have that same variable. When you're combining them, all you're doing is either adding or subtracting that coefficient, that number that's attached to the variable, and then you're leaving the variable as it is. Now you're probably asking yourself, Mr. T, can we combine unlike terms? And yes, but no, and I'll show you how. If we were trying to combine, say, 5x and 6t with addition, we would just come back with the same thing. We can't truly combine them together because they're not like terms. And the same goes with, say, 7t minus 13f. You get back 17 minus 13f because they're not like terms. You can't combine them together. And the reason this works is because when you have a variable and you have multiple instances of that variable in the same equation or the same problem, then it makes sense to put that same term together because it's the same thing, just multiple times, multiple instances of that same variable. But it wouldn't make sense to combine something like x and t because those are completely different numbers. They represent different things. They're different instances of different numbers. A good real-world example has to do with food. Now, let's say you ordered 2 pizzas and 2 orders of French fries. If you were to combine the 2 orders of French fries, you would just get one really large order of French fries. It would be twice the amount of a normal order of French fries. And shapes aside, if you combined the pizzas together, you would come up with just twice the amount of pizza. But if you combined a pizza and an order of French fries, regardless of if you call it pizza French fries or French fry pizza, you've created something new. You've created something different that wasn't there before. It's not more of one thing, it's a combined new thing. And that's how like terms work. If you have 2 of the same variable, 2 of the same type of term, then combine it together, make your life easier. But if you have two different terms, two different types, two different variables, then you can't combine it together, because if you combine it, then you've created something new and you're not after that. Now that I've made you all hungry, let's go look at how we can use this information to help us solve equations. So we have the equation here, 3x plus 4x plus 37 equals 79. Now you notice there's two different x terms. Well, that means we have like terms and we can combine them. So let's do that. When I combine 3x and 4x, they're added together, I get 7x. Now I'm going to leave the rest of this alone. So drop down my 37, my equal sign, and my 79. Now all I'm left with is a two-step equation, just like we were doing yesterday. So that means we have two more steps, and then we've solved this equation. First thing I'm going to do is undo this addition sign here. I want to get all of my constants, all of my normal numbers on one side of the equation, opposite of the variable term. In order to undo addition, I'm going to subtract. So subtract 37 here and subtract 37 here. Remember, we have to do it on both sides. It's because it's still an equation. So what we do to one side, we have to do to the other. So I'm going to drop my 7x down. I haven't done anything to it yet. And these will cancel because we subtracted it out, we moved it. So 7x equals 79 minus 37, which turns out to be 42. Now, all I have left is one more step. I have 7 times x, or 7x. So in order to undo the multiplication that we have going on here, we're going to divide. And we're going to divide by 7 because that's the only number standing in the way of us having that x by itself. When we divide by 7, these are going to cancel out, so we drop our x down. And 42 divided by 7 would be 6. Let's recap for a second. Let's talk about what we just did, because a little more happened than last time. We have the initial equation, 3x plus 4x plus 37 equals 79. We have like terms. We have two x terms. Let's combine them. Let's make our life simpler. When we combine them, we add them together in this case. So we combine them down and we get 7x plus 37 equals 79. Now, all we're left with is a two-step equation. In order to undo the addition that we have here, to do our first step of solving a two-step equation, we have to subtract 37 on both sides. When I subtract 37 here, I end up with nothing. They cancel out. And when I subtract 37 from 79, I get 42. And all I did was bring down that 7x term. I didn't touch it. I didn't do anything with it yet. So we get the equation. 7x equals 42. Now, since we have 7 times x, we have to undo multiplication in order to get x by itself, in order to isolate that variable. To undo multiplication, we divide. So I divided by 7 on both sides. That makes those 7's cancel out, bring our x down, and we divide 42 by 7, giving us 6. Now, I want to give one to you guys to try. So why don't we take a look at the equation x plus 12 equals 40. Take a second, pause the video, work through this equation, come back in a second. Here we have the equation x plus 12 equals 40. I see two like terms. I see two like variable terms. So I'm going to combine them together. When I add x and x, I get 2x. And I'm going to leave the rest of this alone. So I leave 12 here. I put my plus 12. I bring down my equal sign, and my 40. Now I have a two-step equation. Remember, guys, all it is when we're doing this is adding an additional step to make it look like a two-step equation. Make it a two-step equation. So right now, that's all you're concerned about. In order to solve a two-step equation, we look, is there addition or subtraction? In this case, we have a plus 12 here. I want to get all my constants, all my normal numbers together. So I'm going to subtract 12 from both sides. I bring my 2x down, because I haven't done anything to it yet. My 12s will cancel, and 40 minus 12 equals 28. Now, one step left, and I have this variable isolated, and I've solved this equation. I have 2 times x equals 28. 2 times x. So in order to undo multiplication, I have to divide. I divide both sides by 2. So my 2's will cancel, and I'll get x equals 28 divided by 2 equals 14. And that is the solution to this equation. So let's recap what we did today. We talked about like terms, what they are, what they do, and the different... Nope, you scratched. You scratched. Let's recap. Today, we talked about like terms and the different things that we can do with them in regards to equations. Like terms are those terms that have the same variable or they both don't have a variable. Stuff like 7x and 4x or 2 and 3 would be great examples. Examples of unlike terms, or those terms that don't have same variables, or one has a variable and one doesn't, are stuff like 7x, 4, or 4b. None of those have the same variable or the same lack of variable. Then we looked and we took this new knowledge and we used it to help us solve equations. By using these properties, we were able to take a term or an equation that was this big and this long and boil it down to a two-step equation. From there, we followed the same steps that we did when solving two-step equations. Add or subtract our constant term from both sides, then multiply or divide by the coefficient that we had next to our variable term. And we did this to solve for each variable in the equation. Well, that's it for today. You've been the students. I've been the teacher. Thanks for watching. I'll catch up with you guys tomorrow when we start talking about solving equations using the distributive property. I'll see you guys then.